The next concept is theoretical verification of kinetic energy plus potential energy is equal to constant. This is very important. So we are going to prove that kinetic energy plus potential energy is constant. So next concept is theoretical verification of kinetic energy plus potential energy, which is equal to constant. So we have to prove this. Okay. So let us consider, let a body of mass m falling freely under gravity from a height h meters. Okay, that is, let me consider a body of mass m. It is falling on the ground. This is ground. Okay, then we must have to find what happens to the kinetic energy at this point A. So I will consider this point as A. Then in between somewhere here, when the ball is falling towards the ground, when the ball reaches somewhere here, what happens to the kinetic energy and potential energy? I will consider this position as B. And on the ground, when this ball reaches on the ground, what happens to the kinetic energy? Okay, that is point C I will write. Okay, so what happens to the kinetic energy of the ball at point A and the potential energy? What happens to the sum of kinetic energy and potential energy at point B? And what is the sum of kinetic energy plus potential energy at point C? So sum of both kinetic energy, potential energy at A, B and C, we have to check what is the constant value. Whether it is constant or no, we'll see. Okay, so let us consider a ball of mass or body of mass m falling freely under gravity from a height h. So this is height h. Okay, so let us discuss at point A. What happens at point A? What happens to the kinetic energy plus potential energy is equal to constant. What happens to the constant value? What will happen there? We'll see. Okay, so at point M, the kinetic energy will be 0. Why? Body is at rest. Correct? And at point M, at point A, the potential energy will be m into g into h. M is mass, g is gravity because it is with respect to gravity, and h is height of the ball above the ground level. So potential energy is mgh and kinetic energy is 0. Then what is the total energy? Kinetic energy plus potential energy, that is kinetic energy is 0, potential energy is mgh. So it is mgh. So the total energy is mgh. So this is point A. Okay. Now at point B, what happens? You see, at point B, what happens to the kinetic energy plus potential energy? We'll see now. Okay. Now when the ball is moving towards the earth with respect to gravity, it covers some distance now. It is covering some distance here. I'll write it as x. You can take any letter. I will consider this body is moving from A to point B and travels a distance of x meters. Okay. Now we must have to find what happens to the kinetic energy here. As it is traveling, it is not zero because it is in motion. And what happens to the potential energy here? Okay. So first we'll find out what is kinetic energy. Kinetic energy is given by the formula which we already derived, that is half mv square. Correct or no? M is there, v square is not there. Correct? So I'll write this as equation 1. So we have to find the v square. And to find this v, we have an equation of motion. This v square is equal to u square plus 2as. Correct? So v square is equal to u. Initially it was 0, no? U is initial velocity. So initially the body was at rest. So initial velocity will be 0 plus 2 into a is nothing but gravity and s is nothing but x. Why x? Because it is traveling from point A to point B. This is the displacement made by the body. Correct or no? So it is 2gx. We'll substitute this in kinetic energy. So from 1, what we get? Kinetic energy is equal to half into m into 2gx. So to cancel, get mgx. That is kinetic energy. Correct? Still we have to find what is potential energy, no? Sorry, mgx. mgx. Now we have to find the potential energy. What is potential energy? mg height. Now at this point V, what will be the potential energy? And potential energy is depending on height, no? Now what is the height? This is the height we have to consider. Always we have to consider from the ground. Now what will be this height? This total height is h and it has covered a distance of x meters. Then this becomes h minus x. Why h minus x? From this h, this distance covered we have to subtract to get this height. So height at the point B is h minus x. So wherever h is there, mgh, I'll write h minus x. So this is nothing but mgh minus mgx, mgh into mgx minus. So therefore total energy is equal to kinetic energy plus potential energy. Now what is kinetic energy? mgx. What is potential energy? mgh minus mgx. Minus mgx and plus mgx will cancel. So we'll get mghc. The total energy at point B is also